Help eliminate DBF corruption. Help eliminate DBF corruption with a posting engine. FoxTalk May 1999. Copyright Pinnacle Publishing Incorporated. All rights reserved. Help eliminate DBF corruption with a posting engine. Steve Zimmelman. The DBF file has been with us for about 15 years. And while I really like the open architecture of the structure, there's always been an inherent problem with index and data corruption, especially in a network environment. The problem seems to be with the amount of data that's transmitted up and down the network wire. Couple this with multiple users, and it doesn't take long to pop an index. On the other hand, single-user systems appear to be much more stable and don't exhibit the same corruption levels as their networked cousins. One solution, often used by developers, myself included, has been to reindex or recreate the index files when an index-related error rears its head. But this can become unmanageable when the datasets start to approach the 4 million record mark. A long-term solution might be to force the multi-user application to behave like a single-user system by developing what's become known as a posting engine. The theory behind a posting engine is actually fairly simple. The fundamental rule is to never allow the user to post anything directly to the shared table. Instead, the user posts to a shadow table. After the shadow table is populated and no errors have occurred during the post, the application passes a directive to the posting engine, which in essence tells the engine what it's supposed to do. In this case, it updates the main table from the data in the shadow table. So what's actually happening is that the posting engine, or a single workstation, is the only one posting to the main table. This is exactly what a single-user system does. Anatomy of an engine. Most of the posting engines I've seen are able to process a variety of requests by using a table to receive its directives. A simple directive table can have a structure like this: field name, type size 1, ID character 10, 2 program character 53, params character 64, shadow tableau character 55, data request date 86, date done date 87, start underscore time character 88, end underscore time character 89, done logical 110, user ID character 5. The engine sits in a loop and looks for records where the done field is false. When it sees one, it will start to process it using the information stored in the record. For example, let's say an application needs to update a client's record. The application would get a copy of the record and store it in a shadow table. After the user makes the desired changes, he or she clicks on the post or commit button, and the application writes a record to the directive table. The code might look something like this: *-copy customer record to shadow table *- for editing. *select customer if seek m.cust no c temp table equals temp plus write sys 3 4 plus .dbf copy to m.c temp table, while customer.cust no equals m.cust no and if ** when editing is complete, add record to * posting directive table. Insert into directive ID program params shadow table date request user ID done values sys 2015 cust updt.fxp m.cust no m.c temp table date m.userid.f. When the posting engine sees the record, it starts to process the record something like this: if seek.f directive replace directive.start _ with time, if empty directive.shadow table, if file directive.shadow table, use directive.shadow table, alias shadow in 0 and if empty directive.program and file altrim directive.program, if empty directive.params params equals directive.params do directive.program with params else do directive.program and if ** close the shadow table. If used shadow use in shadow and if ** update the directive table. Select directive replace done with .t, date done with date, and _time with time, and if the engine can be a non-visible or visible application. I prefer a visible engine so I can monitor the engine's progress if necessary. The use of a posting engine is obviously not for smaller installations, and it does require a bit re-engineering. But for large installations where data integrity must be secured, it might be the way to go.